So today we're talking about square roots, and we're going to simplify square roots. A square root of a number n is a number m such that m squared is equal to n. So for example, if we want to find the square root of 100, in other words, when we see this radical sign, the square root is a radical sign, we're asking ourselves, like I ask myself, what number times itself equals 100? So we know that 10 times 10 equals 100. So 10 is the square root of 100. Square roots have both positive numbers have both positive and negative square roots. What does that mean? It means that 10 times 10, positive 10 times positive 10 equals 100, as well as negative 10 times negative 10 equals 100. So this sign is the plus or minus sign. This means that the square root of 100 is plus or minus 10. In other words, a positive 10 or a negative 10. If we need to find the negative square root of 100, then this is equal to negative 10. This is equal to negative 10 because the square root of 100 is 10 times the negative. Whatever is outside of the radical sign is what you're multiplying times the square root. That's why the answer to the negative square root of 100 is negative 10. If I ask you to find the square root of 16, what are you asking yourself?
What times 1 equals 16?
So what would you say?
4.
Plus or minus 4? Either one, right? So that's why we use the plus or minus sign. 4 times 4 equals 16. Negative 4 times negative 4 also equals 16. If you need to find the square root of 144, what would that equal? Plus or minus 12. 12 times 12 equals 144, and negative 12 times negative 12 equals 144. If we need to approximate square roots, first let's go over perfect square numbers. So for example, the perfect squares would be 4, 9, 16, 25, 36, 49, and so forth. Why is 4 a perfect square? It's the product of 2 times 2. 9 is a perfect square because it is a product of 3 times 3. 16 is a perfect square because it's the product of 4 times 4. But 25 is a perfect square because it's the product of 5 times 5. 36 is a perfect square because it's the product of 6 times 6. 49 is a perfect square because it's the product of 7 times 7. What's a perfect square after 49? 64. And then 81, 100, 121, 144, and it continues. So let's say we have to approximate the square root of 51. Is 51 a perfect square?
No.
Okay, but 51 is greater than 49, right? Do we know? So 51 is greater than the square root of 49, but it's less than the square root of what comes after the of 64. Are 49 and 64 perfect squares? What's the square root of 49? And what's the square root of 64? This means that the square root of 51 is greater than 7 but less than 8. Now is 51 closer to 49 or to 64? 49. So that means that the square root of 51 is closer to 49. Closer to 7, I'm sorry, than to 8. We can approximate the square root of 51 to be closer to 7, right? This is like rounding a square root. Let's try this again. If we have to approximate the square root of 125, we know that 125 is greater than 121, right? What's the square root of 121? 11. And the square root of 125 is less than the square root of 144. What's the square root of 144? 12. So do you think it's going to be closer to 11 or closer to 12? So approximately the square root of 125 is approximately 11. If we have to evaluate 2 times the square root of a plus b squared, where a equals 11 and b equals 5, we have to substitute a with 11 and b with 5. So 11 plus 5 squared is 11 plus 25. This means 2 times the square root of 36. What is the square root of 36? 6. This means 6 times 2 is 12. To simplify square roots, we need to know the product property of square roots. The product property of square roots says that the square root of a times b is equal to the square root of a times the square root of b. So for example, the square root of 9 times 7 is equal to the square root of 9 times the square root of 7. Now when we're simplifying square roots, we need to remember this property. So for example, if we need to simplify the square root of 180, if we need to simplify the square root of 180, we have to think about the factors of 180 that are perfect squares. So what were the perfect squares? 4, 9, 16, 25, 36, 49, 64, and so on. So what factors of 180 are perfect squares? 36 times 5. Is 36 a perfect square? Yes. The square root of 36 is 6. Now the factors of 5 are 1 and 5. Are 1 or 5 a perfect square? No. So that means that we can simplify the square root of 180 to 6 times the square root of 5. If we have to simplify the square root of 24s squared, let's think about factors of 24 that are perfect squares. 4 times 6. What about the variable? Well, see how there's 2, that means that the square root of s is s. What's the square root of 4? 2. Can I simplify the square root of 6? The factors are 1, 2, 3, and 6. Are any of those numbers perfect squares? So I can't simplify it. Now, I circle my numbers and my variables when I know that I'm done. So that means 2s times the square root of 6. That means that when we simplify, the square root of 24s squared is equal to 2s times the square root of 6. Let's say we had to simplify the square root of 54t squared. So let's start by thinking about factors that are perfect square of 54. So is 54 divisible by 4? Is 54 divisible by 9? Yes, so the square root of 9 times the square root of 6. What's the square root of 9? 3. Can I simplify the square root of 6? What about the square root of t squared? T. That means my answer is 3t times the square root of 6. if you're asked to simplify the square root of 13 over 36, we have to give the square root or the radical to both numerator and denominator. Now, can we simplify the square root of 13? No. Can we simplify the square root of 36? Yes, 6. So this would be the simplified version. Let's say we have the square root of 15 over the square root of 16. Same thing. Get the square root of 15 over the square root of 16. This is equal to the square root of 15 over 4.